The obvious answer to this question is 2. X equals to 2. If this was an objective, I will pick 2 and move to the next question. But if you were to show your working, how would you solve this problem and prove that the value of x equals to 2? First off, how did I know that x will be 2? This is a radical equation, it's a square root. To take away a square root, you need to square that expression. So if I put x equal to 2, the square will cancel out the square root. If I put x here equal to 2, the square will cancel out the square root, and I will be left with 7 plus root 48 plus 7 minus root 48. Of course, 7 plus 7 gives us 14, because root 48 minus root 48 is 0. So the obvious answer is 2. But how do you solve this in an exam, assuming it was a theory question? That is why this video is here, and that is why you want to watch this video to the end and watch the solution. To solve this problem, we want to replace these radical expressions with an alphabet. So let's start by saying, let A be equal to this, and B be equal to this radical expression, so that this original equation reduces to A to the power of x plus B to the power of x equals 14, because this is now A and this is now B from our assumption. To solve further, we want to look for other equations that can help us solve this problem. If you look at this expression A, the inner part of the radical expression is the same. This radical expression and this one, they are conjugate of each other. This is the conjugate of this, while this is the conjugate of this. What it means is that if we are able to multiply A and B, we would have reduced these expressions to a less complex format. So let's multiply. A dot B means the square root of this times this, because the square root of a number times the square root of another number is simply the square root of the product of both numbers. So we have the square root of this and this. This is definitely the difference of two squares, so it reduces to A dot B equal to 7 times 7 gives us 49, root 48 times root 48 gives us 48. Remember, negative. Now, 49 minus 48 gives us 1. The square root of 1 is 1. So the product of A and B equals 1. What does it mean? It means we can be able to write this expression in terms of A and X or in terms of B and X. So let's reduce this expression or this equation to an equation in terms of A and X, which means we need to take out this B. To take out this B, we can write B in terms of A, which means B will be equal to 1 over A. From this equation, B is 1 over A. We can put this value now in the place of B in this equation so that we have an equation that looks like this. A to the power of x plus 1 over A to the power of x equals 14. Now, everything is in terms of A and x, and we can easily solve from here. Looking at this, it's going to be easier if we make A to the power of x another letter. So let's take m to be equal to A to the power of x. The reason is that if we make A to the power of x to be equal to m, we can now reduce this equation to m plus 1 over m equals 14. It is easier to solve for m from here than to solve for a from here. So that's the reason why we have made A to the power of x to be equal to m. Remember, 1 to the power of x gives us 1. A to the power of x is m. That's why we have m plus 1 over m equals 14. To remove this m from the denominator, we multiply through this equation by m, so that we have m times m to give us m squared plus m times 1 over m will give us 1 equals 14m. This is already a quadratic equation because the highest power of the unknown here is 2. Let's write it in the proper form. By bringing this 14 inside to the left-hand side, we're going to have m squared minus 14m plus 1 equals 0. So let's solve this quadratic equation. Let's move to the next page. So on the next page, we have these original assumptions, and then this is the quadratic equation we are solving. If you look at this very well, there are no two numbers other than 1 that you can multiply by itself to give you 1. And when you add them, it gives you 14. What it means is that this equation cannot be factorized. We need to use the general formula method. And this is the general formula method. M equals this. I'm not going to waste time solving this problem because in some of my previous videos, I have solved multiple problems under the general formula method of quadratic equation. So I'm just going to substitute values right away. So m will be equal to minus 14 plus minus this all over this. If you know how to solve this problem, you can get here quite easily, or you refer to my previous videos under general formula method of quadratic equation. Solving further, we're going to have m equals to 14 plus or minus the square root of 192 all over 2. At this point, I want to break this down into the product of 48 and 4. Of course, the square root of 4 is 2, which means this can be broken down into 14 plus or minus 2 root 48. The reason I didn't break down this further, because we can also break 48 further, break 48 down further, but I've not done so because I want this expression to look like this, because we are making m to be equal to a to the power of x. So let's make this expression resemble a. 2 can divide 14 and 2 can also divide 2. If 2 divide 14, you have 7 plus or minus 2 divide 2 is 1, and you'll have 7 plus or minus the square root of 48. So you can see that this and these are very similar, or these are very similar. That is why I've left it in this format. Plus or minus means m can be used to solve. Assuming we equated it to a to the power of x, we're going to use the positive value. If we equated it to b to the power of x, we're going to use the negative value. That is why we have plus or minus here. Since we made m to be equal to a, we are going to use the positive value of this solution, so that m will be equal to a to the power of x from our assumption, and that will be equal to 7 plus square root of 48. I've taken out the negative because a to the power of x, because we're using a, and a is the positive solution, so we've left this as positive. Now let's solve further. What is a to the power of x? If a is this whole expression, then a to the power of x will be this expression, right? So that means a to the power of x will be the first expression in the question, and it's also equal to this, because a to the power of x is m, and m is this. So we now have this simpler equation. To solve this further, we are going to consider this equation and this equation. This equal to this. Now take a look at something. 7 plus root 48 is the same thing as 7 plus root 48. The only difference is that this has a square root. We can equally put a square root here without changing this equation. What do we need to do? We put a square root here and we square it. This is what I mean. This raised to power x is here and is equal to, we take a square root of this and we equally square it, because the square would cancel out the square root and we'll be left with this original expression. So nothing has changed on the right hand side. But most importantly, we have got very close to our solution, because what is here is equal to what is here. It means the bases are the same, therefore the powers should be the same, and we can conclude that x equals 2. So this is the answer to the question. A very interesting video, you will agree with me, and I believe you enjoyed it. If you did, please support us by liking this video, subscribe to my YouTube channel, the link is in the comment section, and always keep supporting Knowledge Base. I will be anticipating your questions and your comments, and I will be there to respond to them. Thank you for watching this video, and hope to see you in our next video.